Welcome to the training of the SolidWorks Essentials module. In this module, we will be covering from the introduction of the software, learning about the basics and some advanced part modules, as well as going through the assembly modeling done in SolidWorks. Let us go through the introduction of CAD. We have three classifications in design engineering: CAD, CAE, and CAM. CAD, or Computer Aided Designing, deals with the creation of 3D models in products like SolidWorks. CAE, or Computer Aided Engineering, applies the advantages of simulation on these CAD models. Computer Aided Manufacturing, or CAM, helps you develop languages that can be fed to CNC machines using these CAD models. Our intention and goal is to learn SolidWorks CAD. Let us understand some basic definitions about 2D and 3D. What do you think exactly 2D means? Well, the most probable answer that I get is two-dimensional. So what is 3D? Well, nothing but three-dimensional. Though we all know what is 2D and 3D all about, we are still unable to explain it in a very simple language. Let me explain you the concept of 2D and 3D using this coordinate system. We have three reference axes in a coordinate system, namely the x-axis, the y-axis, and the z-axis. These three axes form reference planes in 3D CAD modeling softwares. The x and the y-axis forms the front plane, the y and the z-axis forms the right plane, and the x and the z-axis forms the top plane. The front plane is depicted here in blue color, the right plane in red color, and the top plane in green color. So now let me come back to my question. What is 2D and what is 3D? 2D, or two-dimensional entity, is any entity that lies on a single plane. If I make a rectangle or a circle on the Z plane, that is the front plane, it is a 2D entity which has a length and a width but no thickness. Any entity that expands in more than one plane and requires more than one plane to define it is known as a 3D model. The 3D model will have a length, a width, and a thickness value associated with it. Now that we have understood what is CAD and what is 2D and 3D, let us come ahead and understand what is SolidWorks all about. SolidWorks Mechanical Design Automation software is a feature-based parametric solid modeling design tool which takes the advantage of the easy-to-learn Windows graphical user interface. Let us now understand the terms used in this definition. Feature-based. Just as an assembly is made up of a number of individual piece parts, a SolidWorks model is also made up of individual constituent elements. These elements are known as features. Features can be of two types: sketched features and applied features. Sketched features are those features that are made from sketches, like the one that you see in the circle over here. The circle is the sketch for the cylinder. Applied features are those features that are directly applied to the 3D model and do not require sketches to be made. The fillet and the chamfer commands are a very good example of the applied features, wherein the commands are directly applied to the edges of the 3D model. Parametric. The dimensions and relations used to create a feature are captured and stored in the model. This not only enables you to capture your design intent, it also enables you to quickly and easily make changes to the model. A solid model is the most complete type of geometric model used in CAD systems. It contains all the wireframe and surface geometry necessary to fully describe the edges and faces of the model. In addition to the geometric information, it has the information called topology, which relates the geometry together. A SolidWorks model is fully associative to the drawings and assemblies that reference it. Changes to the model are automatically reflected in the associated drawings and assemblies. Likewise, you can make changes in the context of the drawing or assembly and know that those changes will be reflected back in the model. In order to use a parametric modeler like SolidWorks efficiently, you must consider the design intent before modeling. Design intent, or your intention for design, is one of the most important factors often ignored in design practice. While learning the software or following our daily routine of modeling practice, we tend to concentrate more on the commands rather than our intention of creating the basic design. Let us see an example over here. We have 3 sketches on the screen, each sketch consisting of a rectangle and 2 circles. You would notice that the dimension scheme in all the 3 are different. Given the size of these 3 sketches, you will notice that the geometry remains the same. The dimensioning scheme varies between every sketch. So the question is, which is a better way of dimensioning this sketch? Is it the first one? Is it the second? Or is it the third one? Well, most probably people answer as the second one. So the first circle is 20 millimeters from the left edge and the second circle is 80 millimeters from the left edge. Well, the answer is all 3 are equally important and unique in their own ways. It just depends upon your design intent. Let us see a typical example. Let us change the dimension 100 to 150 in all of them. You will notice in the first one that because we are changing the dimension to 150, the right edge moves by 50 millimeters. The circle, which was actually associated with the right edge, has moved with it and maintains its 20 millimeter dimension. In the second sketch, when we make the 100 dimension 150, the first circle remains intact with the left edge. The second circle, as it is also depending upon the left edge, remains at the same distance. Let us now change one of the dimensions of the circle to 40 millimeters. You would notice in the first sketch, the circle moves by 20 millimeters to the right. It does not affect the other circle because it maintains its distance of 20 millimeters from the right edge. In the second case, the first circle moves by 20 again. The second circle remains intact. But you will notice in the third sketch, because the first circle is moving by 20 millimeters, the second circle has moved as well, because the dimension of the second circle is with respect to the first. So you may now notice how different dimensioning schemes or ways to dimension a particular sketch could change the model completely when you are trying to edit it. Which is the best solution out? Which is the best way of dimensioning it? Well, it depends upon you. How would you like the model to behave when you edit it? That's what you need to think, and that's your design intent. Before we go further into the software, let us understand a little bit about how the hardware interaction happens with the software. Here we have the fixed disk, that is the hard disk drive, and the RAM. So what does the fixed disk do? Well, it stores files, it stores data within itself, so that even after your computer restarts or your system boots up again, you still have the data available with you. What does the random access memory, the RAM, do? Well, it stores the memory temporarily. So when you are actually restarting your system, the data in the RAM gets wiped out. Any data or any file that you try to access from the hard disk actually opens up in the RAM. So when you mention RAM speed, that basically means how fast a document could open, close down, or how fast could you edit a particular document. SolidWorks is a RAM resident CAD system. Whenever a file is opened, it is copied from its storage location to the computer's random access memory or the RAM. All changes to the file are made to the copy in the RAM and only written back to the original files during a save operation. So the question is, what synchronizes the work between the hard disk and the RAM? Nothing else but the chip. So when we mention chip speed or the processor speed, That basically means how fast our RAM would interact with the hard disk and how fast our documents could open as well. Let us understand certain save commands that are available in SolidWorks. We have 4 types of save commands available in SolidWorks. The simple save, which saves the current open file to the hard disk drive. So say for example, if you have a file open in front of you and when you hit the save button, it actually writes that file back to the hard disk drive, so your file document gets saved at that stage and is also available after you reboot or restart your system. Save as enables us to save an open document as a different name in a different folder or the same folder. If you have a file name A, you can save it as file name B in the same folder or at a different location. So what does the save as command do? Well, it makes a new copy. So what does the save as copy command do? Save as copy command saves a file A with a new name B, again in the same location, in the same folder or at a different location. So it makes a new copy as well. So the question is, what is the difference between save as and save as copy? The answer is simple. In the save as command, when you save a file name A as file name B, the new file B remains open and the old file A closes down. In the save as copy command, the old file A still remains open and the new file created, the file B, closes down. So the save as copy command is a better option to take a regular backup while working on your current model, still ensuring that the model you are working on remains open. The save all command saves all the open files that are open in the SolidWorks software. So are you now interested to go ahead and check out the SolidWorks user interface? Well, let's do it. The SolidWorks user interface is a native Windows interface and as such behaves in the same manner as other Windows applications. We have the menu bars on the left top of our screen, which consist of different commands included in the tabs of menus like File, Edit, View, Insert, Tools and Windows. This is the standard toolbar, where you can open a new document or an existing document or use the save commands that we learned earlier. On the left of your screen, you will see the Feature Manager. The Feature Manager design tree is a unique part of SolidWorks software that visually displays all the features in a part or an assembly. As features are created, they are added to the Feature Manager design tree. As a result, the Feature Manager design tree represents the chronological sequence of modeling operations. The Feature Manager design tree also allows access to the editing of features that it contains. The next is the Property Manager as well as the Configuration Manager. This region also consists of the DIM Expert Manager and the Display Manager. The group of commands on the screen on the graphical interface is known as the Heads-Up toolbar. These are the most commonly used commands for orienting the model. Our model is located in the graphical user interface. This is the actual work area that we model our products on. On the right hand of your screen, you will notice the Tasks pane. The Tasks pane has various tabs related to different functionalities. You have the Design Library, which consists of the Toolbox, a collection of all the hardware components that are readily available in the market, following different standards. You also have the File Explorer located in this region. You do not need to minimize the software to search for a file on your PC. You can just click on File Explorer and browse through the relevant location on your desktop. You can also see the preview of the component when you move your mouse cursor over it. You have the View palette for the drawings as well as the appearances and scenes located in this region. At the bottom of the screen, you notice the status bar, which constantly gives you a feedback about your sketches and your models. You can have access to toolbars in SolidWorks using the right click on this particular region. So if you want to use a particular toolbar, you just need to click it over here to switch it on. SolidWorks is very much customizable, so you can place the toolbars at a very convenient location that is the best for you. This is the main area of the command manager. The command manager is a set of toolbars geared towards helping the novice user, working alone or to perform some specific task. For example, the part version of the toolbar has several tabs to access commands related to features or sketches. SolidWorks is very much customizable. You can just click on the options over here and click on Customize, or access the Customize bar from the Tools menu and by clicking on Customize. You will notice that you can customize toolbars, you can customize commands, you can customize even the menus, as well as the keyboard shortcuts. Mouse gestures can be put in place so that when you move your mouse to a particular location, a set of command automatically takes or comes into existence. You can also access the options available in SolidWorks by clicking on the Options tab or going to the Tools menu. When you click on the Options icon, you will notice two tabs, the System Options and the Document Properties. The options grouped under the heading System Options are saved on your system and affect every document you open in SolidWorks. System settings allow you to control and customize your work environment. For example, you may like working with the colored viewport background. Well, I don't. Since this is a system setting, parts or assemblies opened on your system would have a colored viewport. The same files opened on my system would not. The document settings are applied to individual documents, for example, units, drafting standards, and material properties like density. They are saved with the document and do not change, regardless of whose system the document is opened on. So we like the way we work and we customize a lot of things on our screen. But when it's time to shift our system or when it's time to format our system, we notice that whatever customization we have done on the software is lost. Is there an easy way to carry on this customization or carry forward this customization to another system? Well, just go to SolidWorks Tools in your Programs list and you can click on the Copy Settings wizard. The Copy Settings wizard would save all the customizations and settings you have done on your system, and you can carry it to another system. In this chapter, the Introduction to SolidWorks, we plan to get comfortable with the SolidWorks user interface. Thanks for watching this video and best of luck for your training.